Multi-agent systems are moving from demos to production, but when a chain of LLM calls, tools, and sub-agents fail at 2 a.m., teams still grab for logs and guess. Many enterprises already use Splunk for security and operations. They should not depend on a second observability stack just for agents. That's why me, Aditya, a MSCS grad from USC, came up with a solution called AgentGuard. So what is AgentGuard? AgentGuard instruments multi-agent AI systems with a lightweight Python SDK, streams execution traces into Splunk via HTTP event collector, surfaces failure patterns in real-time SPL dashboards, and exposes a Splunk MCP server so Claude can query telemetry data to explain why agents fail. I will move on to the system design to explain it into further detail. Coming to the system design, there are two parts to it. The first is the telemetry ingestion, and the second is the AI diagnostics flow, in which we can connect the Splunk MCP to the Claude MCP so that Claude can query telemetry data using natural language. Let's just move on to the demo where we are going to just ingest demo agents into our Splunk enterprise. Here you can see the Splunk enterprise where all the agent actions have been traced. Now we can just move on to the Claude workflow, wherein we can just type our natural queries in English. Here we have used the main index, as index is the one which is used as a query parameter. And again, agent guard is to be mentioned in the query, just so the Claude gets more specifics about it. Other than this, just my natural language, we can just write which agent crashed, what was the simulated error, and what were the system metrics immediately preceding the error. Now it's going to run some SPL queries which are going to give us more information about the agent traces and in-depth analysis to what exactly went wrong. Now these are connected to demo agents. If you had real agents, this would still work in an. So as Claude is just running our query and just concluding what agents were at fault, I'll just conclude by saying what I learned. Essentially this project solidified my belief in model context protocol as the future of the infrastructure management. I learned how to seamlessly translate raw and structured multi-agent execution states into high consistency JSON for Splunk ingestion. More importantly, I first hand saw like how pairing structured operational data with an LLM's runtime reasoning shifts the industry from a reactive monitoring to a proactive self-diagnosing systems. And that's it from my side. This was my project for the Splunk Agentic Ops Hackathon. Thank you for listening to me.